So, ayan, our topic ay it's all about column capacity concept. Tatakal dito ay yung introduction, classification of columns, types of columns, rules of column design, axial load capacity columns, and axial load and bendings. Introduction. Una, ano nga ba yung columns? Yung columns ay ang vertical structural member na nagtatransfer ng compression load sa foundation ng isang structure or building. Classification of columns. Yung columns ay naka-classified siya as short and long columns. If the height of the column is less than 3 times its least lateral dimension may be considered as short compression blocks or pedestal. And yung pedestal ay hindi na siya ginagamitan ng reinforcement at ang kanyang maximum permissible compression strength ay 0.85 FC. At meron siyang modification factor na 0.65. If the compressive strength is greater than this value, the pedestal will have to be designated as reinforced concrete short columns. If the reinforced concrete column fails due to initial material failure, classified siyang short columns. Tapos yung load ng short columns ay nakadepende sa dimension and then sa strength ng material kung saan siya gawa. If the length of the column is increased, the changes that will fail by lateral buckling will be increased. Columns that fail by buckling are called long columns. Ayan yung example. Rules of column design. Tiles detail. Concluded column rebar. Dito sa video is, nandiyan yung rules of column design. Papakita yung mga mistakes and corrects sa paggawa ng columns. Rules of column design. So now, let us talk about the types of columns. First is we have this plain concrete pedestal. May be used only if the height does not exceed 3 times the least lateral dimension. So, mako-consider siyang pedestal if yung height ng column is 3 times nung dimension ng cross-section niya. So, dito sa plain concrete pedestal, hindi na siya kailangan pang gamitin ng reinforced. Ang maki-carry alone na dito ay yung concrete lang. Kasi yung short columns, ang nire-resist lang niya ay yung compression stress. At if ever naman na magkaroon ng tension sa isang side, dun na papasok yung other types of columns or yung mga steel reinforced. Ayan na nga yung next is yung tied columns. A longitudinal bars are braced with a series of closed ties. Since transverse reinforcement ang ties niya, pwede siyang rectangular or square columns. Next ay yung spiral columns. A longitudinal bar and concrete core are wrapped with a closely spaced helix or spiral. Yan, as you can see, circular yung shape niya since yung reinforce niya ay naka-spiral. Ayan, nakapalibot dun sa longitudinal bars. At ang huli ay ang composite columns. Ano nga ba tong composite columns? It may contain a structural steel sheet surrounded by a longitudinal bars with ties or spiral, or may consist of high-strength steel tubing filled with concrete. Ayan. Itong si composite column ay composite siya kasi nga pwera sa reinforcement niyang mga bakal, meron pa siyang let's say wide flange sa loob. Kumbaga, meron siyang structural steel sa loob na yun yung tumutulong sa kanya para mas ma-carry yung loads.
Continuation sa report ng JONA. So, action loads capacity of columns. Action loads without moment is not practical case in design of columns, but a discussion of such a space is necessary for explaining the theory involved in eccentricity loaded columns. For a column subjected purely by an action load, the nominal load Pn that it can carry is the sum of strength of steel, which is Fy, area of steel reinforcement, and the strength of concrete 0.85 F is equal to area of gross minus area steel reinforcement, where area of gross minus area steel reinforcement is the net concrete area, or equation is 5 minus 1. Pn is equal to 0.85 Fc, quantity area of gross minus area steel reinforcement plus Fy area of steel reinforcement. To the counter effect possible eccentricities, the nominal strength is Pn is multiplied by 0.0 for the right column and 0.85 for the spiral columns. Finally, the ultimate actual strength of the column is N, where is 0.65 for right column and 0.75 for the spiral column. So, mostly, pag nagde-design ng column is hindi naman laging hindi lang action loads ang ginagamit kasi hindi lang linya pino-consider. Pwede din kasi yung load is wala sa pinaka-center ng column. Kaya nagkakaroon ng eccentricity kasi yung eccentricity which is yung proportion of moment. Kapag mas mataas kasi yung eccentricity, mas mataas din yung moment. Tapos ayun yung kung paano kuhain yung action loads. Pagdating dun sa may nominal strength, yung 0.85 na pang spiral column, tapos 0.85 80 naman for tight columns. Tapos yung ultimate action strengthening mo multiply lang siya sa reduction ng reduction factor depende kung anong types ng column yung gagamitin. The action load capacity of tight column is given by. So, ayun yung computation for the action loads. Tulad ng sa kanina. So, yung AD is the gross concrete area and yung P is equal to area of steel reinforcement. Yung ibig sabihin. So, unit of reinforcement for tight columns. Area of steel reinforcement shall not be less than 0.1. Area of concrete gross concrete area and area of steel reinforcement shall not be more than 0.8 0.08. So, hindi daw pwedeng mas mataas pa dun sa 0.08 gross concrete area. Tapos, the minimum number of longitudinal bar is 4 for the bars within rectangular or circular ties. 3 for bars within triangular ties. So, yun yung minimum ng bar na nakatayo dun sa ating column. Size and spacing of main bars and ties. Free distance between longitudinal bar shall not be less than 1.5 distance north 40 mm. So, kailangan yung distance ng line ng bawat bar is hindi dadagdag bababa ng 1.5 diameter bar or 40 mm. Use 10 mm diameter ties or 32 mm bar or smaller, and at least 12 mm in size for 36 mm, 42 mm, 8 mm, and bundle longitudinal bar. So, pag, yun nga, 10 mm pagka 32 bars, 32 mm bars yung ginagamit or mas maliit pa. Magtataas tayo at least 12 mm bar ties, diameter ties. Pag mas mataas na yung size ng bakal. Vertical spacing of ties shall not exceed 16 or 48 times diameter, 48 times diameter or this dimension of the column. Ties shall be arranged such that every corner alternate longitudinal bar shall have lateral support provided by the corner of the tie with an acute angle of no more than 135 degrees, and no bar shall be farther than 115 and clear on each side along the tie from such as laterally supported bar. Where longitudinal bar are located around the perimeter of a circle, a complete tie is allowed. The action load capacity of a spiral column is given by. So, ito din yung kanina na same value na or same formula na ginagamit to compute the action loads. Limit reinforcement bar for spiral column. So, limit. Area of steel reinforcement should not be less than 0.01 gross area, concrete area, and shall not more than yung ating area steel reinforcement ay hindi kailangan tumaas ng 0.08 ng area ng gross concrete area. So, the minimum number of longitudinal bars is yung mismo nagamit na bars na is 6 ang kailangan natin. Or yun yung parang pinaka-minimum na ginagamit. In the beam, 60% to 70% of this section under the tension assumed to be cracked. The section can be made economical by making the tension part smaller in the area. As in I or T, the column where all the concrete is under compression, saving can be made by using percentage of longitudinal percentage. Since reinforcement bar are quite expensive, this can be accomplished by using larger column size and or higher strength concrete. So, yung sabihin is 60 to 70% na yung naging tension doon at nagkakaroon na ng crack o ng basag dun sa may ating beam, pwedeng gawing mas maliit yung tension dun sa part ng I-beam mo sa T-beam. Kasi yung columnar on the compass, pag under compression yung mismong beam, mas makakatipid kung mas maliit yung percentage na gagamitin na tension dun sa may area. Tapos sa may longitudinal percentage. So, kung mas mahal kasi yung mga bakal ginagamit for the longitudinal bar, mas marami. So, maging accomplish yung ganung pangyayari kapag gumamit tayo ng mas malalaking column, mas matataas na column para mas maging mas matibay yung foundation nating column. Special mount frame members and technical bending in action with the requirement of the section of like a special moment frame member. The existing activities indicate first B, having factored action comprehensive, first B exceeding area, gross concrete area. Over 10, the shortest cross-sectional dimension measured on a straight line passing through the geometric centroid shall not be less than 300 mm. The ratio of the shortest cross-sectional dimension to the perpendicular dimension shall not be less than 0.4. Minimum textural strength of the column. So, textural strength of any column proportion to resist the exceeding area gross concrete area of retention satisfy the following. The textural strength of the column shall satisfy the following equation. So, sa minimum ng textural strength area, yung sinusunod, para maging proportion yung column, yung sinusunod na equation na ginagamit which is na nakikita naman natin sa screen. Para makuha ng proportion yung isang flexural string column. Longitudinal reinforcement. Area of longitudinal reinforcement, area of steel reinforcement shall not be less than 0.01 gross concrete area or more than 0.06 gross concrete area. So, sa longitudinal, pinapakita nito yung minimum and maximum ng longitudinal reinforcement area or yung kailangan niyang hindi siya bababa ng 0.01 na area gross concrete area at hindi naman siya tataas ng 0.06. So, transverse reinforcement shall be provided over a length from each joint and face and on both sides of any section where textural yielding is likely to occur as a result of inelastic lateral displacement of the frame. Length shall not be less than the larger of the following. So A is the depth of the member of the joint face or the section where the flexural yielding likely to occur. Letter B, 1/6 of the clear span of the member and C is 400 millimeter. Transverse reinforcement shall be provided by either singular or overlapping hoops. Crossing of the same bars, size, and spacing as the hoops shall permitted. Each end of the crossty shall engage a peripheral longitudinal reinforcement bar. Consecutive crossties shall be alternated end for end and along the longitudinal reinforcement. Spacing of crossties or length of rectilinear hoops within a cross-section of the member shall not exceed 350 mm in the center. So, dun sa transverse reinforcement, merong kailangang sundin din para mas maging maayos and more hindi magkaroon ng failure dun sa mismong falling. Kailangan mag-provide tayo ng singular overlapping hooks. Tapos kailangan din na yung crosses, and may same bar siya, may same spacing siya as the hooks na permitted din sa ginagawa. So, kailangan consecutive din yung alternated ng longitudinal reinforcement. So, yung cross stitch is kailangan ay consecutive sunod-sunod na alternated from end to end, sa dulo sa dulo. Tapos, within the cross section, kailangan hindi mag-exit ng 350 mm yung cross section niya dun sa mismong center ng column. Action loads and bending. Action loads and bending. All columns are subjected to action force as well as some of bending. We need to proportion to resist both force the load capacity by equation 5 minus 2 and equation 5 minus 3 are only applicable upon a centricity of 0.10 for tied column and 0.5 for spiral column. Column will tend to bend under the action moment, which is produced compression on the side of the column. The tension on the other side, the following failure are possible under the combined action and bending load. So, yung action and bending load. So, lahat na ng column ay subjected or merong isang parang selected na force sa lahat ng column. Meron siyang parang list na or ganun na dun sa bawat isang column. As well, pagka magbe-bending yung column, kailangan ng proportion para ma-resist niya yung both force sa column. So, katulad nga nung kanina sa action load kasi, pag mas mataas ang eccentricity, mas mataas ang moment. So, nakadepende din yun kung ang ginagamit is tied column or spiral column. So, dito na naman is ipapaliwanag lang naman dito yung iba't ibang klase ng moment. So, tsaka yung failure na mangyayari based sa laki ng eccentricity. Diba? So, pag lumala yung eccentricity nga, ang laki din yung moment. So, this first week, number one is large action loads with negligible moment failure under this condition of early crashing of concrete with all reinforcing bar in the column having reached yields stress compression. So dito, pinapakita na sa malaking action loads na negligible moment. So, mas malaki action load dito, mas mataas din ng centricity, mas mataas yung moment, nagkakaroon ng failure under compression. So, yung condition ng column na to is pinakrush nyo yung sira na yung concrete. Nagbibigyan ng stress kasi nandito sa pinaka-center ng column yung plastic centroid. So, andun yung force sa may pinakagitna kaya nagkakaroon ng failure. Pangalawa is third action loads and small moment with the entire cross-section in comprehension. Failures to the crushing of concrete with all the bars in compression. So, ayun, wala. Yung dito naman sa pangalawa is wala naman siya sa center. Ando siya sa may gilid. Ganun din kasi mas maliit yung moment ito, pero ganun din. Nagkakaroon siya ng failure kasi kinakrush niya yung nagkakaroon ng force, may kakrush niya yung concrete. Ibibigyan ng compression lahat ng bars na nandun sa may column. Action loads and bending. Number three, large action loads with moment larger than 8. Bars in the far side, the tension but have not yield. Failures for the crashing of concrete. So ito, may isang large action na may uh, large moment, like larger than number 2. So, mataas ang moment, mas mataas din ang eccentricity. And yung naging failure niya is kinakrush niya din yung concrete at nagkakaroon ng tension dun sa bundok kasi nalipat na siya sa may pinaka gawing dulo na ng volume. So, yun yung doon niya kinakrush yung concrete malapit na sa may pinakadulang part ng uh, bars natin. So, number 4, balance loading condition bar intensive yield. At the same time, concrete in the compression side crash at 0.85. So, ito ay yung versus nasa labas na, pero kasi maging balance na yung loading condition niya. So, okay na, tensile yield. At the same time, yung concrete compression niya sa side, hindi na sa side nagka-crush, pero hindi na totally nagkakaroon ng failure, di mismo sa loob ng volume. Number 5 is large moment relative small action load failure initiated the yield of tensile bar. So dito, mas malaki yung mas large yung moment niya, pero mas maliit yung action loads. So failure initiate the yielding of tensile bar. So nag-initiate yung failure dun sa first dun sa may tensile bar natin. Number 6, large building moment. Failures occurs like a beam. So, dito, sa large bending moment is yung dahilan ng pagka-failure niya is from the beam. Kasi nagbe-bend over na yung beam. Nagbe-bend over yung beam kasi parang sobrang layo. Hindi na din na kinakaya ng volume. The plastic centroid of the column cross-section is the point through which is the resultant column load must pass to produce uniform strain in failure. It represents the location of the resultant force produced by the steel and concrete. The eccentricity of a column load is the distance from the load to the plastic centroid of the column. Separating the plastic centroid of all concrete is assumed to be the stress comprehension in 0.85 and all the steel to FI in comprehension. And the centroid is then located by taking moments due to this force for symmetrical section. The plastic coincide with the centroid of the column cross section. So yung plastic centroid, ito yung kanina nandun sa may sample. So ito yung resultant ng column load na kailangang malagpasan para mag-produce ng uniform strain sa failure na nangyayari dun sa ating column. So siya yung nagre-represent ng location dun sa resultant force na mag-produce ng ating steel tsaka ng concrete. So, yung eccentricity ng column na nagbibigay ng layo dun sa may load tsaka sa column, itinatawag na natin yung plastic centroid. Yung sa paglalagay ng plastic centroid, kailangan lahat ng concrete, na-assume mo na stress siya para magkaroon ng compression na hanggang 0.85. So, tapos, yung centroid is kailangan nakalocate din sa paglalagay ng, nakalocate siya base sa paglalagay ng moment due to this force for symmetrical section. So, column interaction diagram, it can be seen that the analysis of column with statics equation is very tedious and complicated as a result. Designer resort to diagram a computer is designing column. Interaction diagram is a plot that actual load and that the column can carry versus its moment and capacity. This diagram is very useful for studying the strength of the column, which varying proportion of loads and moments, and any combination of loading the falls inside the curve is satisfactory, whereas any combination that fall outside the represent failure. So yung column interaction diagram. So, makita siya dun sa pag-a-analysis ng static equation. Medyo tedious and complicated yung pag-a-analysis nito. Sa interaction diagram is the plot of action loads. So, parang yung nagsisimulan din or pinakalatag ng action load natin. So, siya yung magkikarry din dun sa may moment. No, the column can carry versus the moment. This moment ng mismo versus ng moment ng mismo column, moment capacity ng column natin. So, itong diagram ay pag-aaral, column interaction diagram is pag-aaral talaga ng strength ng column na nakadepend, strength ng column na para ma-proportion yung loads sa anong moment ng column na dinidesign natin. So, lahat ng combination ng loading that falls inside the curves is satisfactory. So, hindi satisfying yung lahat ng combination ng falls na loading na magpo-falls dun sa mismong dinidesign na column, yung satisfactory. Whether combination man siya, pero nagre-represent siya ng failure. So, thank you po. That's our report by JONA, LIZA, and QUIAMBAO and Carl and Rich Pausa.